Please, Professor.
Thank you, Chairman, ladies and gentlemen. It's a pleasure to meet you again. I was supposed to give this talk in September in Jeju Island, but I even purchased a ticket, but there was a super typhoon landing, and everything shut down, including the highway service, airport, so I couldn't make it. Fortunately, we still have this chance in the end of this year, and I would like to thank Professor for organizing this meeting and invite us here. It's great, and you did a wonderful job, right? Why don't you guys give me the big hands? I'm waiting for your response. Thank you, Professor Wonkook. Come on. We need to find more time to get together. Okay, anyway, I'm going to give this talk. This is something I'm doing, and I will keep continuous work on this subject. It's got a very good name, OASIS, Open Access Satellite Image Service, currently only for Taiwan area. And ironically, but later you will think it's logically to have this image as the first slide of this talk. This is the last image of Formoset 2. In the June 20th, I think this year, after taking these images, a few days later, Formoset 2 stopped to surface. Well, actually the last image is still very good. If that's image taken 1 year before, and we make comparison like we usually did, and we can find out where is the new landslides. We can identify this area and provide this information to the government. We have been relying on this kind of data, this kind of service for many years. It was launched in the year 2004, but this year, in June, the last set of reaction wheel doesn't functioning very well. And of course, we make several attempts to try to restart, just like a computer. Every time you have a blue screen, what do? Restart the computer, right? But it doesn't respond. And of course, we would try to make some aggressive approach, but there are some risks, especially still in the orbit, and if anything's happened out of control, and we cannot afford that. So eventually, make a decision to decommission, to let go Formoset 2. And of course, after 12 years, its design lifetime is 5 years. And after 12 years, they make some statistics. And of course, it took a lot of images. And we are waiting for the follow-on sensor, Formoset 5. And it was scheduled to be launched in October. So we thought, that's fine, just a few months gap. Unfortunately, another disaster. You probably have watched this, not our satellite, it's Facebook. It's, I download this video, just 40 seconds, it's interesting. You can take a look. Because if you take a closer look, you can see something happening here. Do you see that? Just before the explosion. So somebody suspect might be some fighter jets from Russia or UFO. Well, nowadays anything could happen. Well, I don't care what is that thing, but I don't want to see that thing when my satellite was launched in the future. Because originally, Formosat 5 was scheduled to be launched by SpaceX, but after this disaster, everything was delayed. So Formosat 5 was seriously delayed as a consequence. And so everybody asked, when is the time? But nobody knows the answer. So we are facing the problem. We are entering the era of post-Formosat 2, or you can say no Formosat 2. How do we survive? And of course, after so many years, there are a lot of commercial satellites available, and they provide very high quality images. But of course, they charge. As long as you have money, you can get anything you want from the market. But in the meantime, technology progresses very fast. And there are some open data, including GEODAC from good friend here from Korea. Okay, and these satellites also provide a lot of possibilities. So if you take into account the cost, the spatial coverage, and the spectral bands, maybe this is an even better choice, right? But why do you go to commercial satellite? Is it just because spatial resolution? Of course not. I think the most serious problem of this open data is there's no urgent need, or there's no big market. Why is that? It's because nobody knows how to use that except experts like you. Everybody here, you are experts, but not the general public. And they even cannot see the images. Is that true? Yes. Although it's free, but if you ask a high school student, can you download the image, decompress the image, process the image? I guess the answer is no. So there's a serious gap between the data, the good data, and the users. That's the reason we try to provide this kind of service. We want to let satellite images to be open, and that should be something worthwhile to do. And in other words, we not just want to fill the gap, we also want to open a new door to utilize the open data images. And thanks to our friends from Korea, from Japan, we have some agreements, we have some collaborations. So now we've been putting these two data sets online for Taiwan area. And I've been talking about GEODAC in several conferences before. So today I'm going to focus on Landsat 8. Okay, everybody, a lot of people are familiar with this program because it is the earliest and the longest Earth observation program, right? All the way back to 1972. And now it's Landsat 8. To make the best use of this data, they even have this kind of international collaborator network. If you join this network, you can buy the license, you can have your antenna, you can receive the downlink data and process the data. GEODAC taking charge of this. They even provide you the system, including software, document, everything. So you can process the data to level 1 product. But the problem is, level 1 product is 1 gigabyte size, even it's compressed file. It's a huge data file, right? And this map shows the existing ground station. There are 17 ground stations receiving Landsat 8 data, including one in Japan. And that's why we collaborate with AIST, because this one covers Taiwan area. So we are supposed to get the real-time data just 1 hour late from Japan. Okay. But even with these 17 ground stations, and they have license, they have the software, but if I ask you to check what's the latest Landsat image of your area, I think it's not that easy to answer, right? You have to go to the USGS to download the data 1 gigabyte and decompress and do the processing. And you even cannot find where's the place you live. So we summarize what the general publics need. I'm not talking about experts like you. I'm talking about the general publics. They like to browse the most up-to-date, the latest, the new one. And if possible, all historical images. They want to see what happens in the past of their regions of interest. Maybe not that big, but that's what they're concerned. They want to have full resolution from all kinds of device, even the cell phone, computer, everything. Wherever they want, they can check the images, right? And without tedious data downloading, decompressing, and processing. And even though Formoset 2 is not functioning anymore, we have acquired a lot of experience. So 2 years ago, we start to move everything from Formoset 2 to Landsat 8, and we signed the joint research contract with AIST. We developed this Landsat 8 automatic image processing system based on Formoset 2. So the idea is to provide the near real time. I'm not talking about the real time, but near real time browsable Landsat 8 imager. The goal is to be automatic and fast. So this is our benchmark. We run everything in an ordinary PC. You know, it's just i7 guys. You can get this from Amazon very cheap. And there are 4 steps. All you need is 10 minutes to process one scene. Okay? So now I'm going to explain what are the steps. This is a standard Landsat 8 scene. For Taiwan, we need 5 scenes to cover. Okay? If you take a closer look, it has a multispectral band, 11 spectral bands. But these are 30 meters resolution. Only one panchromatic band has 15 meters resolution. So of course you like to have the highest spatial resolution. So first thing, we decompress everything and resample everything to 15 meters resolution using bilinear interpolation. Then for land application, very important thing is you have to get rid of clouds. That's very important. I read a paper in Korea. You are doing the same thing for OASIS data for land application. And fortunately, USGS has been working on this for a long time. Now they released a new algorithm called FMask, and CFMask is called C, something like that. And you can download their algorithm and run the program and generate this snow, sorry, it's in Chinese, snow shadow and cloud, snow, shadow, snow, water, and land. Anyway, you can have 4 different masks. And don't get it wrong, it's so many masks. If you zoom in, actually, it's quite accurate. And they claim the accuracy is as high as 96%. You can check. And so it's very convenient. You just run this CF mask, and you can have 5 different masks for different land cover. And it takes only 1.5 minutes to do the processing for one scene. Then we want to do the pen sharpening, right? We want to have 50 meters resolution. For the case of Formoset 2, the panchromatic band covers 4 multispectral bands, except there's a small gap. So based on this assumption, we can neglect this part, so we can distribute the energy of panchromatic band to different spectral bands. So we can do this kind of pen sharpening without losing the spectral information. So that's what we did. If you want to read the details, please refer to our papers. Okay. And for Landsat 8, fortunately, it's roughly the same thing. The panchromatic band covers band 2, 3, and 4. That means only true color. And for band 2, not all of them, but part of them. So you have blue information, and you can use these small portions to evenly enlarge. So you can apply the same principles to do the spectral, to do the pen sharpening. This is one example of Taiwan area, 30 meters resolution if you do the pen sharpening. Maybe it's not that clear, let's blow up this, that's 30 meters, that's 15 meters. Should be better, right? And this image was taken after the big earthquake early this year. I'm sorry to my friends, I sent an email to bother you because the earthquake was in my hometown. I thought you might wonder what happened. So I wrote an email. And after that earthquake, Taiwan government sent a lot of aircraft to take air photos. So I have this high resolution aerial photos, 25 centimeters of this same area. And what I would like to emphasize is the spectral information is correct. Okay, we can have the true color composite from Landsat 8 imagery. And it takes only 12.5 seconds to do the pen sharpening. And third part is to enhance the image. Usually for optical images, the cloud is something you cannot avoid. Okay? One number is 52% of the ground, the Earth's surface, land surface is covered by clouds. So usually you will have an image like this, poor contrast. And if you apply something like linear contrast, it's useless because a cloud will saturate everything, so you cannot stretch them out. And if you apply something we call adaptive contrast enhancement, still not very good and give you some strange color, weird color. That's because cloud is there and it causes the problem. And because we have already used USGS cloud mask, so we can remove everything and do the contrast, then add back the cloud. Actually, it's not cloud. I just add back 255 saturated digital numbers, and then you won't feel anything wrong, and you can see a very clear images. And that's the key thing to have a good contrast, a good image. And this part only takes 20 seconds. Finally, we want to distribute the image through internet, so every user can easily access them, but it's a large image. This is not a new technology. 10 years ago, they have already developed this kind of technology, image pyramid, and Google uses this quite a lot. The idea is if you have an image and you can generate a different level of details, and if you want to see the details at different levels, you just access those image types. So it's not difficult. And we have a program to do this automatically. But this takes the longest time. For the one thing, it takes more than 400 seconds. Usually we publish this through Google Earth or Google Map API, but last year Google made a decision. They stopped the service, and that caused a lot of problem. Now we move everything to open layers, so it's open. We don't need to worry about Google anymore. So now the OASIS service is provided by open layers. This is the interface. You can check if you like, and it's very easy to memorize. oasis.ncku, that's my university, edu.tw. If you put Landsat 8, then it will take you to this screen. And we have already processed all Landsat 8 image of Taiwan area. There are two strips, left and right. If you click any date, it will overlay the images. Click another one, so two strips covered in Taiwan. And if you click this symbol, it will download the JPEG image. Of course, it's compressed image, but at full resolution, you can open this file in your computer and view this image at full resolution with the best contrast, all the details. Okay. So this surface has been put online. Next question will be, why bother to do this? Is it useful? That's something I try to convince my founding agent. Okay, because they get used to 2 meters resolution, formal set 2. When they hear 15 meters, they shows no interest. But that's something you can overlay onto Google Earth. And I can say, with Landsat 8 image, you can have this kind of animation every 16 days. Update every 16 days, of course. Maybe you will have clouds. And now I'm going to give you 3 examples. That's what happens this year. In July, this year has been a crazy year. There's a lot of typhoon, a big typhoon attacked Taiwan, and it caused a large-scale destruction of vegetation. And this image was taken right before typhoon. Sorry, the date is. Okay. This was taken 1 week before typhoon and 1 after typhoon, Hoang County. So if you make a comparison, there's no big difference, right? But if you go to Taidong County, the colors change significantly. Okay? So we send along to the soil and water conservation group. We say there's a large-scale vegetation destruction of vegetations. It might cause a landslide in next typhoon. But they say, is that true? They doubt. But if you compare this, that means our images has been processed to the same radius level, and these are different. So they send an aircraft to take an aerial photos, and that's the aerial photo. And if we enlarge in the full resolution, it's very clear the vegetation is gone. So later they lower down the threshold of rainfall. In the typhoon season, they have a warning for landslide for this particular area because of we send this image to them. Another example is also the same typhoon, but after the typhoon, nobody knows there's a barrier lake formed in the mountain area. Why do we have this image? Because there's a guy. He went to the mountain and he found this barrier lake, and he mentioned to his friend. Then we took, this is a high spatial resolution, 50 centimeters. We processed the image and we found the barrier lake. Next question is it caused by this typhoon? But we cannot afford to buy another historical image, or there's a lot of dates. Which day should we choose? Then we get another image, take 1 day earlier. It is due after the typhoon, and we can see, barely can see the barrier lake. And that was former Set2 image taken 1 year earlier, so there's no barrier lake. Now we can go to Landsat 8 archive because we have already processed all the image. We just specify the region of interest, and that's the image taken 2 weeks. Now 1 week before typhoon, no barrier lake. And after typhoon, and 1 week later, Landsat 8 image, the lake is still there. So this image is give a very good example. 15 meters resolution might not be good enough to look at your car plate. We cannot tell the numbers, but it's good enough to deal with this kind of nature disasters. Okay, so that's a second example. And the third example is, again, another big landslide, but this is serious because in near Taipei City, a big one. But actually, it was triggered last year by another typhoon. But this year, it is still there, and we can compare these 2 dates. And we realize there's a new landslide triggered within this year. So that means it's developing. And if you trace all the way back, you see there's no landslide there. So this also highlights the serious problem of this area. There's a lot of new landslide and it is ongoing to develop. Okay, so these 3 examples convince my funding agent this is something we need to do. Okay, so we are going to apply this Landsat 8 archive to do the monitoring, especially we have no photoset imaging. And this is another example for GEODAC. Sorry. Okay, let me quickly finish this. I have explained what we have done in previous workshop. If you go to this website, all GEODAC images has been processed and put online. Okay? And you can select the date you want. And we have also did some contrast enhancements because of clouds. And we want to see the details of the roof. So we remove the cloud, do the contrast, and add back the clouds. Although sometimes you will feel the color is a little bit weird, but I can guarantee the contrast is the best. And you can also zoom in to the region you like and do the animation. So this is another example. We can use the open data. And of course, we have also used the image matching techniques to derive this kind of path line. And several papers have been published, including Yang from Korea, and this year there's another guy from mainland China. They also published a paper. But there's also, I think that is for feasibility study. They only deal with cloudless things and just doing 1 or 2 examples. But if you want to have a product, you have to deal with clouds. You have to have confidence to get rid of those clouds. So this morning I'm talking to Anne about this issue. We would like to collaborate, make this operational product. And this is the last slide. Apart from GEODAC Landsat 8, actually there are some good images around. Sentinel-2, launched by ESA, now is operational and it's 10 meters resolution. And only one pass can cover entire Taiwan. This is one example with this. And very good quality. Okay. And revisit time is 10 days now. Next year they are going to launch another one. So the revisit time will be 5 days. So we are going to be flushed by images. The question is, are we ready or not? So that is my talk. Thank you very much.
Thank you very much for the presentation of the Professor Cheng-Chien Liu. Now we can discuss, have 1 or 2 minutes for discuss. How do you question?
Thank you for the information. Now I deal with business by using remote sensing. So do you have any plan to cover not only Taiwan area but also world data? This is one question. And another is also I want to use API for your services, even Google stop to release. So this is the question.
Thank you for asking this question, because the spirit is open. So of course, the data is not my data, it's open. So we would like to provide this service, but it still needs some cost, right? Like the computer, especially the storage network. So my idea is to have this system up and running, then go to Landsat 8 meeting, because there are 17 ground stations. They are 17 users. If they can have the system up and running, then they can provide this kind of product for their area.
Yeah.
Yeah.
So it's most difficult for business because we need historical data.
Yes.
But on the other hand, it's data cost to collect data. So yeah, this is.
You can download all data
Yeah.
from USGS, but it takes time. My students take a few months to download everything every day, and our computer has been locked several times, and so we are hackers. No, we are not. I think that's not a big issue. You can get all the historical data, no problem. Or Singapore, or any place you like.
All of Asia.
Thank you. One more question?
Dr. Liu, thank you very much for your interesting talk. Have you tried to compare your service with Google? Google provides many services, including Google Earth Engine, for example. It's very powerful, and I'm a user of Google Earth Engine. What's the advantage of your system compared to their services?
Yes, thank you. Thank you for this important question. I submitted a manuscript and it's being revised, and the reviewer asked the same question. He even gave me 3 websites. They are providing a similar service. One is from Centennial too. They have a private company called Centennial Hub, and they charge. That means if you register, you pay money, then you can have this service. Another one is from Canada. It's a guru. It's a computer guru. He provides a free service, but there's no contrast enhancement. There's no pen sharpening. They are computer guys. They can do the processing very quick, but they don't know remote sensing imagery like us, right? So I reply the review comments, and I'm waiting for the final result. So my answer is that yes, indeed, there are several services around, but they don't consider this kind of pen sharpening and contrast enhancement. And for Google a few months ago, they just announced they update their archive. They use the latest Landsat 8 imagery. But if you go to their website, if you go to their archive, they only select the cloudless signal, and they will do the updates maybe every year or every 2 years. But Landsat takes more images, much more than that, right? So if they can apply this technology, then their database will be much richer, much more information. So I haven't got a chance to talk to Google people. Maybe they will be interested in, maybe they can give me some money to buy this. Oh yes.
They already have all the data.
Google. I'm sure, yes.
Also, NOAA,
Yes.
our group we downloaded all the data from.
See?
Yeah, but not from USGS. So you can easily, but yeah, of course your tool is quite good, but.
Thank you.
Thank you.
Thank you. Next presentation, Dr. Eko Sibanto for the present the topic illusion the high primary relativity in the chlorofluor surface water of the East China Sea.